Right. Hope everyone can see my screen. Welcome to Multimodal Weekly. This is a virtual webinar series hosted by the team at TwelveLabs. For some of you who are new, we a startup focusing on building multimodal video understanding models. So this initiative is an effort that I've been running over the past 3 years or so. We've been meeting on a weekly basis, and these are the type of topic that we tend to cover. We have a lot of researchers coming in and talk about their new work on foundation models and multimodal AI, especially in the early days when the field was pretty nascent. Then we have customer and partners come in and share various application of multimodal in a variety of different verticals. As our community grows, we have developers coming and talk about a variety of different projects that they build with using our technologies. And occasionally, there are tutorials and guides from our internal team members as well. These are some samples of projects that of session over the past month. So you can see there were research talk on video reasoning. There are application talk on spot highlights and social recommendation. There are a few hackathon projects on sport broadcasting, education, etc. Last week was a session with a couple of our partners on specific use cases on real estate promotional videos. So for today's session, number 109, super excited to welcome some of our friends from Pixeltable. So Alison Hill, who's the VP of Product, and Marcel Kornacker, who's the CTO and co-founder. They will walk us through the process of developing a production-ready cross-modal video search system, combining TwelveLabs Marengo 3.0 model with Pixeltable's declarative data infrastructure for multimodal AI. So, if you been following our company for a while, you know that our focus is on multimodal embeddings, and the power of that is that it can enable unify, semantic space where image, audio, text, and video together can combine and then enable any-to-any search. So in this scenario, our integration with Pixeltable is very powerful because their product handles the complexity of embedding computation, indexing, and incremental updates automatically, and therefore letting developers to focus on building new features rather than managing infrastructure. So we do have a couple of blog posts and asset that will be shared throughout the session today, and probably put the attendees as well after the session ends, so that you can take a look and try out this new integration and build a really cool application on top of our partnerships. Since it's a pretty small group, feel free to send your question on a Zoom chat, and I'll surface them async with Alison and Marcel as they present. And after they finish, we can also have a live interactive Q&A session as well. So with that, I'll stop sharing my screen. And yeah, Alison, do you want to go ahead and get started?
Yeah. Looks like participants can now see my screen. Is that accurate?
Yes, we can see it.
All right, great. Thank you. So welcome, everybody. Thanks for joining us. We have 4 topics today. I'm going to start with just an introduction to Pixeltable, pretty short and brief, give you guys an idea of what Pixeltable is and why and when you would use it. Then we're going to walk through a notebook. It's based off of the notebook that James shared in the meeting announcement for this meetup. We'll walk through it together. It's also in a GitHub repository. You'll have access to it after the meetup. And then I'm going to have Marcel Kornacker, our founder and CTO of Pixeltable, talk through some of the technical details. So in the notebook, I'll walk you through some of the how-tos in Pixeltable, and then he'll provide more insights into how it actually works, why it was designed that way, and the technical architecture details. And then we'll leave some time for Q&A at the end. So jumping right in, I assume that you all are avid multimodal AI developers. So the problem with AI development today, as I'm sure you're familiar with, is if you start with the problem of I want to make a searchable collection of videos, you've just embarked on a journey with at least 8 steps and much more glue code that you have to write. So here's an example stack that we're showing here on the right. And you can see that every single arrow is a place where you're probably writing custom code to be able to connect to S3 buckets, to be able to connect to different APIs, to be able to parse and validate the outputs, generate embeddings, store those embeddings, be able to handle failures, and about 1,000+ lines of glue code in, and you're still trying to figure out how to get versioning, get observability, lineage, scalability, parallelization, and how to actually optimize this whole pipeline that you've built so that it's something that you can put reliably in production. And usually at this point, when I'm presenting this kind of graphic, I get a lot of like, yes, that is exactly my stack, or that is exactly my pain. So hopefully that's resonating with you all. So one thing that we continue to hear over and over again from Pixeltable users is that AI development today is mostly plumbing and pipelines. About 80 to 90% of the effort is connecting all these different disparate pieces together. And writing the code to be able to support that often feels like kind of this heroic journey, right? Where you're trying to get all these things to talk to each other that weren't meant to talk to each other in the first place. And what's left behind is a lot of the things that you'd actually want, features that you'd want to be part of your development platform. So you can find a great model like TwelveLabs, get really excited about all the possibilities. You can do text search, image matching, audio matching, video recommendations. But the reality is often that you're stuck in this morass of dealing with storage, indexing, sync, error handling, caching, versioning, lineage, parallelization. So why Pixeltable? Pixeltable solves that problem for you. So as James teed up for us, Pixeltable is an open source Python software development kit. You can find us on GitHub. Pixeltable allows you to store, transform, index, and iterate with all different kinds of data. So one of the big unique pieces of Pixeltable is our multimodal type system. So you can think of it almost like a CSV file or a Google Sheet that knows how to work with text, images, video, audio, all within a single API. It allows you to track changes and maintain data lineage. So all of the changes that you make as you're working with your multimodal data are tracked automatically based on the processing that you do in Pixeltable. It allows you to scale processing efficiently, and it's made to be able to move from development to production. So what I'm going to show you in the notebook in a moment is really more of a development and iteration workflow. But what we're building up is a system that you can easily streamline and move into production without needing to do any kind of migrations or code rewrites. So how do developers use Pixeltable today? We have 3 primary use cases. So the first is building backends for multimodal AI applications. So this is usually users who are more like AI and app developers. They want to build an AI-powered application. So here's an example, one that one of our partners is working on, where you're taking screenshots and allowing users to be able to input a search term, you're finding the right screenshot, and then you're also generating an additional image on top of that to be able to give them some variations of that image. So this is a way to add multimodal intelligence to applications using Pixeltable as an intermediate or full backend. And if you look at our docs.pixeltable.com website, you'll be able to see some of the notebooks that allow you to walk through the entire workflow for how to do that. A second use case is multimodal dataset curation. This is often for machine learning engineers or data scientists building up training or evaluation datasets. So the use case for Pixeltable there is really as a system of record. All data, cached results, and references stay in sync with each other. And we also have a service on Pixeltable Cloud called data sharing, which allows you to be able to publish datasets in the cloud and easily enable any Python user to be able to replicate that locally using Pixeltable. And then the third use case is building multimodal agents and MCPs. So this is for agent builders and AI engineers. They're individuals who want to be able to build autonomous AI agents with memory and tool use, but they're going to need to be able to work with multimodal data. So you can call tools, remember context, and integrate with MCP servers backed by Pixeltable's persistent storage and orchestration. So why use TwelveLabs with Pixeltable? I assume that the fact that you're here means that you're already really excited about using TwelveLabs models. So you're probably in a space where you'd like to be able to take a batch of videos and be able to search them and find useful things in them and be able to build useful things with them. So the way that you could do it yourself is at least 8 steps. You're splitting things into segments, you're extracting audio. A lot of times you're using different SDKs for the different media types. So working with audio versus working with text versus working with video, working with images. And again, this is a place where you've got different error handling across all these different SDKs and no transactional guarantees that are unified. So to get from video to search, You could just use Pixeltable with 12Labs. Pixeltable allows you to do any workflow that you want to code up in Pixeltable, but combining it with 12Labs allows you to really simplify this and be able to just split videos into segments, add embeddings, and then be able to search. And so that's the notebook that we're going to walk through today. So just to wrap up, Pixeltable is really designed to be an operational data platform for multimodal AI. So it's a single system for all data storage. So it includes structured data, media data, and ML-specific data. It's a single API for all data access. So it's tabular, it's simple, it's intuitive. If you've worked with tables in memory before in Python, for example, and pandas, data frames, then you're going to be very familiar with this tabular interface. But now it's basically infused with different media types and the ability to add computed columns with generative AI applications. It also has observability built in. So the table itself is a log, and the schema of a table is the actual orchestration. And I'll show you what I mean by that in a moment in the notebook. And then finally, it gives you efficiency and parallelization. So declarative API enables cost-based optimization and fine-grained parallelization. So I'm going to skip over to the notebook demo, but while I do that, if anybody has any questions, we have Marcel Kornacker here, as well as Aaron Siegel from the Pixeltable team. So if anybody has any questions as I'm queuing that up, we can handle those. Otherwise, let's see. I cannot see what you all are seeing. Are you seeing my full screen right now with a notebook?
Yes, we can see it.
Cool. Thank you. All right. Okay. So in this notebook, I'm going to walk through building up a cross-modal video search workflow with 12Labs and Pixeltable. So as James mentioned, we're using the Marengo models here, and that projects text, images, audio, and video into the same semantic space. So that means that a text description, a still frame, an audio clip, and a video segment of the same moment all will land near each other in the embedding space, and you can search all of them with this single index. So I'm going to walk you through all these different types of queries: text to video, image to video, audio to video, and video to video, and how you can do them all with a unified API in Pixeltable. So the prerequisites here are that you have a 12Labs API key, and then note that all audio and video content must be at least 4 seconds long. And Pixeltable does give you some utilities for being able to do that on the fly. So I'm not going to run through this interactively because some of the cells require a little bit of computation and time. So I'm going to kind of scroll through and try to go slowly as I scroll. So the setup here is you can pip install Pixeltable. I'm importing Pixeltable as PXT and then importing Pixeltable functions, which I'll note throughout the notebook as PXTF. So anything that you see where I prepend PXTF to it are built-in UDFs, which Pixeltable enables you to be able to work with different media types with specific built-in functions. So for example, there's video functions, image functions, audio functions, et cetera. So every media type has built-in functions, but you can also define your own UDFs to be able to customize processing as well. This little section here, PXT drop dir and create dir, this is just me creating a namespace in my Pixeltable directory for this demo. So if you're running this fresh, you can do that, but know that this will wipe out anything that you've already done if you do work through this and generate your embeddings. So getting started in Pixeltable, we're going to talk through setting up a table structure that will allow us to collect videos, split them into segments, and index those segments. And then that's going to lead us into the search portion. So in Pixeltable, the way you start is to create a new table. Here, I'm creating a table with a handle called half. I'm using create_table, and I'm putting it in the directory 12labs_demo, and then I'm naming it halftime_show. I kind of couldn't resist. We had a really great halftime show on Sunday, and I just enjoyed watching it so much. So heads up, some of these clips that you might be segmenting and searching for if you do replicate my notebook could be not safe for work, depending on where you're at and what's on your screen. But it's a really joyful performance, and it had a number of different cultural moments in it, and I just loved it. So I thought it would be fun visually to be able to index it and see how the search worked. So here I'm creating this table with a single column called video, and I'm using pxt.video as the column type. So you can imagine if I had an audio file, it'd be pxt.audio. So these are where the Pixeltable media types come in. And so this is just an empty table at this point on this line. And it has a single column, which is video. And then in this notebook, I'm going to keep adding columns to the table schema as we build out the workflow. But this is how you would view the table schema in a notebook. If you just type the handle of it, it shows you the schema, and you can see that it tells me the type, the column name, and then computed with. And we'll be filling those in. So right now, this is an actual column that I'm going to just insert a file into, but we'll get up to the point where we have some computed with columns as well. So at this point, I have this empty table. I can insert single or multiple rows into this table, and you can always add new rows at any time to your table. Here, I'm going to insert videos as rows, where each video corresponds to one row. I'm just going to start with one, and it's just a clip of the halftime show. I limited it to 5 minutes so that I could more easily do this demo. But you should know that the video itself can live wherever you want it to. And so if you look at the Pixeltable docs, you'll see some documents on data import, for example. So we give you examples of working with local paths, which I'm using in this example, but you can also reference media files and HTTP URLs, as well as in cloud storage like S3. So scrolling down, I'm going to insert this 5-minute clip. So I set my video URL to be this local file, and then I insert this video URL into my video column. So now I have a table with a single row in it. And in Pixeltable, I can use collect to run a query. Here, since I just have this one video, I'm just going to do collect straight up, but you could also combine this with limit, where in is the number of rows that you want to see in collect. You can also do head in or tail in to retrieve just the first or last n rows of a table. So this gives you some flexibility as you're working to be able to peek at the data. So if you actually saw the halftime show, this might look familiar. So this is the halftime show that aired at the Super Bowl last Sunday. I thought it was really great fun. It starts off not actually in the arena, but it goes into the arena pretty quickly. So that's the video that we're going to be working with. And since it's 5 minutes long, I wanted to split the video into segments before doing the embeddings so that my search was more useful. So the way I'm going to do that in Pixeltable is to use what's called a view. And views are a core orchestration element in Pixeltable. So views essentially allow me to create a new derived table on top of that parent table. So you can think about that parent table with the single video in it as a base table, and then I'm going to build a view on top of that. And a view can be anything. It can be filtered by a column value or some other subset of rows in a parent table. And this allows you to be able to use views to quickly experiment with some expensive operations. And it's really cool because any update that happens to the parent table will flow through to the view. So the two tables are interlinked with each other. And here I'm going to use a special kind of view called an iterator view. This allows you to expand each row in that parent table into a variable number of rows in the view. So it's essentially like going to explode out, create a new table that's based on my parent table and chunk it all up. Since I'm working with a video, I'm going to use what's called the video splitter iterator, but there's an iterator for all kinds of different media types. So you can imagine taking an iterator to expand one document into one row per chunk, for example, to expand large text strings into one row per sentence, an audio file into one row per clip, et cetera. So the number of rows you get really depends on the length of the input and what kind of arguments you give to the iterator. So one thing to note with a view is that you can't insert rows directly into a view, so it needs to inherit from the parent table and flow through to the view. So this really keeps those two in sync and makes it extremely useful for orchestration. So I'm going to split this 5-minute video into segments using PXTF. So this is a built-in video function called the video_splitter. I'm taking the video, splitting it up into segments that are about 12 seconds long, and I've set the minimum segment duration here to be 4 seconds. And you can see that this executed for me locally 30 seconds to be able to generate 25 video chunks from this 5-minute clip. So you can peek at the first few rows. And when I create an iterator view like this in Pixeltable, it does an implicit join on the parent table. So that means that you can see I have this parent video showing up on every row, but that doesn't mean it's duplicated. It's just a reference to the original video, but it's giving me the context because a lot of times you'd like to be able to pull in data from the parent table. And this means that in an iterator view, I don't have to monkey around with joins or figuring out how to bring in data from another table. It's all just carried with it in the view, but it's not duplicated. So these are just allowing me to be able to see my video segments in relation to the video that I just chunked. So you can see that my first segment is obviously position 0. Segments start at 0 seconds, segment ends at about 17 seconds, and you can see that I could play it here. And if you could hear the audio, you'd be able to hear it as well. The next segment is 13 seconds, and so on. And you can get pretty creative here. We actually recently added scene detection in Pixeltable so that you can actually split by scenes, for example. So there's a lot of different ways that you could chunk this up and leverage that video splitter to create views that are more interesting to you for your embeddings later. So I'm going to show you the schema for our iterator view. So the iterator view I named video underscore chunks. So you can see it says it's a view of video chunks here of this one. So this is where we started from, TwelveLabs demo halftime show. And you can see that I now have a number of new columns that the iterator has added. So position it provided, segment start, the segment start presentation, I believe, PTS presentation timestamp, segment end, and then video segment is also there. So you can actually just see the video that you just chopped up, which is really convenient. And then it carries through from the parent table, the original video that we started with. So I'm going to add an embedding index using TwelveLabs Marengo. And in Pixeltable, an embedding index can be added to any column. And in fact, you can actually add more than one embedding index to a column. And in a single table, you can add embedding indexes to any of the columns in there. So it's a really flexible way for you to be able to compare and contrast different embedding indexes, different methods for being able to create embeddings. So here I'm using this add underscore embedding index function. I'm indexing those video segments and I'm providing the model with this function that we developed as part of our integration with TwelveLabs, pxtf.12labs.embed using, and this is where you specify the model name. So you can see that took about 15 seconds for us to be able to call out to the TwelveLabs API, generate those embeddings. And if I look at the table schema again now for this view, you can see that I have this new index down here below. So it's got an index name, IDX0. You can see that I indexed the video segment column. You can see the metric, and you can see the actual function used to generate the embeddings. And so that's the setup for being able to work with embeddings in Pixeltable. So what just happened? Pixeltable sent each video segment to the TwelveLabs embed API, stored the resulting vectors, and built a searchable index for you. Now, whenever you insert new videos into that parent table, everything will update incrementally. So the iterator view will split the new videos into segments. The TwelveLabs API will compute embeddings for only the new segments, so it does incremental updates only, and then the index adds the new vectors. So you don't need to re-index, you don't need to reprocess existing data. You can just trust that it does the right thing for you and kind of helps you fall into the pit of success. So that's how you get to cross-modal video search in Pixeltable with TwelveLabs. In Pixeltable, we have a pseudo function called similarity, which allows you to search based on this embedding index that we've just created. It supports a search parameter, any of the modalities that are supported by your embedding function. So TwelveLabs supports all of the modalities that I'm going to show you here, so you can use any of them for search, but it depends what's available based on the embedding function that you choose. So because TwelveLabs enables me to be able to take this embedding from this video and search with text, I can use the string argument with the similarity function. And here, this line is just saving that as sim, just giving it a variable name. And then I'm showing you how to query those results with ordering it by similarity. So I'm just going to show you the top two most similar results. So if you watched the halftime show, you'll know that an actual wedding ceremony took place. You can do a string search for a wedding ceremony, and these are the top two results. And in fact, I think one of them does actually include a proposal that happens before the actual wedding ceremony. And obviously, if you're doing this and trying to get really fine-grained with the scenes and the detection, then you'd chunk up the video into shorter segments. And also, I think the fact that Bad Bunny was in a white suit makes everything look like a wedding. Okay, so that's the text to video search. Now we can also do an image to video search. So the same index handles image queries. Here, I'm going to use a reference image to find the segments that are visually closest to it. So this is the reference image that I'm going to use. And I'm just going to show you the top two results. So it shows you the video segment and also showing the score. So you can see these are the top two most similar clips for the scene that I provided. So search number 3 is audio to video. So here I'm taking an audio clip from a Bad Bunny song. So providing Yo Perreo Sola. as the matching pattern here and doing a similarity search there. You can see all I'm changing each time is whether this is string or audio at this point, string, image, or audio. It returns video segments again and tells you the score. And for search number 4, we can do video to video. So here I'm taking an example video clip that I pulled from the actual show. I believe it was the orchestra players who are playing string instruments. And so it finds, obviously this one is a pretty high similarity score. This is the actual scene that I put in as a clip to search for. But you can see the top 3 scenes there. So one cool thing about how we developed the TwelveLabs integration is that you can also narrow the embedding context here. So for video embeddings, Marengo can focus on specific aspects of the content, whether it's just visual, audio, or transcription. So basically, you can tell it to kind of put its blinders on and just focus on one of the 3. By default, it uses all 3. So here you can see that we're adding this new argument called embedding option, and we're specifying visual here. And so here you can see I'm showing the actual visual embeddings that come out from TwelveLabs. And then finally, to wrap up, switching gears away from the halftime show, TwelveLabs also provides beyond video, text, image, and document embeddings. So this is a really great example of one of the interesting ways of being able to create multiple embeddings in a table. So I'm creating a new table here that has some just demo content. It's got 3 columns: title, description, and thumbnail. We have a string and a string here, and then an image here. So if I create those, I can add an embedding index first to the description. So one of my string variables, I'm adding an embedding index there, and I'm actually giving it a name this time. So I'm giving it idx_name description index. And then I'm applying one to the thumbnail as well, to the image. You can see here, when I scroll down and I look at that table schema, I still haven't actually inserted any rows yet into the table, but you can see that the schema is all set up for me with 2 indexes there. And you can see the different functions used to be able to create those embeddings. So then when I insert, I can insert just in batch. These are inserting 4 images with a title and description alongside them. I can search by text description. So here I can find all of the images related to outdoor nature adventures. And you can see that it finds, mountain hiking and beach sunset as the top 2. This is searching by image similarity. So using an example image, you can find the top 2 related images that it finds through that search. And then you can also do cross-modal. So I can search images by text. So this is searching for the string animals in the wild, and you can see that it locates the giraffe and a wildlife safari. So that's a brief tour of building up an embedding index and video search in Pixeltable and TwelveLabs using the Marengo models. And now I'll pass it to Marcel to walk through the technical details of Pixeltable. So Marcel, would you like me to run your slides?
Yeah, please.
Okay.
Thank you for queuing it up.
All right.
Okay, yeah, let's launch into some explanations of what we just saw. We already had a bunch of questions, and so I think it's good to address them and give more detail on what Pixeltable is and how it works. So, as Alison mentioned, this is really meant for engineers to create data applications that use generative AI typically. The goal of Pixeltable is to remove the need for engineering data plumbing in your application. So it's a data infrastructure. It's a tabular interface. It's basically a database system at its core that understands multimodal data and allows you to express orchestration. It doesn't do the orchestration. It doesn't choose the algorithms that you want to use for processing for you. Right? The point is to free you from engineering data plumbing, but it doesn't have any, I want to say, built-in video processing functionality. Right? It kind of relies on the models that you choose to use, etc. So you still have full freedom to create applications the way you want them to, right? You choose all the algorithms. It's not a sandbox environment. It's not low code, no code. But you don't have to think about the data plumbing aspects of your application anymore, right? And we'll see how that works. That data interactions are now declarative, and which allows you to focus on the actual algorithms that you care about. So it is available as an open source Python package, which you can pip install locally. And we are working on a cloud service to also give you the ability to run things in the cloud. And so this is what you're getting if you're installing Pixeltable locally. It uses various storage mechanisms. One is that it installs Postgres with pgvector locally to use for structured storage. So basically structured data, integer strings, etc., go in there. And also obviously JSON data, but it also knows how to talk to external object stores and what to do with your file system. So that when you actually, what we just saw, an example of inserting a video URL into a table, it understands that if that is remote, that it might have to download it before there's any local processing. So, and then what we also saw is we did a bunch of data update operations like insert and then also queries. And they, for those, the Pixeltable runtime kind of decomposes them into a plan that knows what to retrieve from the underlying structured storage and then runs it with an async executor that knows how to talk to external endpoint providers. And so these are all available at the moment built in as user-defined functions. And as Alison pointed out, you can also write your own user-defined functions for whatever custom logic your application requires. I mentioned that Pixeltable is a database system. We just saw we created a table that started out with a single column video. So the idea is, and just to reiterate this, a database system means that the tables are persistent. They don't go away after you close the process, right? So just like if you use Postgres directly or you use Snowflake or BigQuery, those tables all stay around and you can keep adding data to them. The same is true for Pixeltable. With Pixeltable, it also understands multimodal data types. So you can now have column types such as document, image, audio, video, and also array and JSON. And just to go back to the database aspect, all update operations, such as you can insert, update, delete rows into tables, and all of those are run transactionally. So if you insert multiple, it'll either all of it will succeed, or if there are failures, you get informed of that as well. For a database system to be complete, you also want to be able to retrieve your data. And so you have basically a comprehensive query language expressed through Python constructs. So here, Pixeltable allows you to do, select where and join operators, basically mapping to, SQL fairly directly, if you're familiar with that. You can store JSON in your application in the tables, and you can use path expressions directly in Pixeltable to pull out the relevant pieces of your complicated JSON structures. And again, the Pixeltable runtime, when you write a query that might be more complicated than the one you see there on the right-hand side, knows how to kind of break it down into an execution tree that retrieves data from the underlying structured storage, knows when to fetch data from an object store, and then runs whatever processing logic can only be done in Python, and uses an asynchronous execution model, especially for external API calls. So you get basically parallelism for free from that execution model. I am looking at the questions right now. Maybe take a little break here. Search query related individual names. Okay. So back to orchestration. So far we talked about the database side of Pixeltable, and that's very familiar if you've worked with relational database systems before. The what sets Pixeltable apart is also the fact that orchestration is now incorporated into the table structure. So the basic concept is that of a computed column, and in this case, the computation can be arbitrarily complex. So we see some examples there, in small print on the right-hand side, where we're adding a computed column to a table that contains videos, and it runs an OpenAI transcription model. And so what this will do is it will, under the covers, actually, and this is done on an audio chunk in a table. So we looked at chunking, or we looked at audio earlier. Audio is a supported column type. And if you want to transcribe something, you would simply, as you can see here, utilize the transcription UDF and simply pass it the audio column and then specify a model. And so what this will do is every time you insert a new row into this table, it will then run the transcription function, which calls out to the endpoint and so forth. And it is able to do parallelization within a row and across all the rows. So if you insert 1,000 rows at a time, it will be able to run through those fairly quickly. So the whole point of this is that now the table structure is maintained automatically and incrementally. So every time you add a new row, it knows how to run through the entire computational DAG that you created with the computed columns in the table. So computed columns can reference other computed columns, which allows you to build up complex pipelines that have a lot of inherent parallelism in them. So here in this example on the right-hand side, we see that the table here called audio chunks has a somehow it's not listed, but it has a transcription text. I guess it's cut off, unfortunately. So, but there are two computed columns, both the actual transcription and then the text field. The transcription output of the transcription call is a dictionary. So this would be a JSON column. And then for convenience sake, we create another computed column that pulls out the text field into a separate text column. And so we saw specifically in the demo that we want to often create embedding indices on any of the multimodal columns. So here, in the example, in the demo, we saw examples on video and audio and images. And so what you basically do is you declare an embedding index on a particular column. This can be any column in any table. So, you're only limited by what your embedding model can support. So in this case, what we're seeing here is we're just using a standard clip model from our Hugging Face collection of UDFs. And clip supports text and image embeddings. And so you can use this on any text or image column. If you used what we saw in the demo, a TwelveLabs model, you could use that on any text, image, audio, and video column. And so you are not limited through Pixeltable on the models that you can use. Any new model, any improvements, TwelveLabs might next week release something on point clouds, and then you'd be able to index that as well. The important part here is also that just like any other computed column, indices are also maintained automatically and incrementally. So if you add new data to a table, the embeddings will be computed for the new rows and the index will be updated just with the vectors for the new rows. So again, you don't have to do periodic rebuilds of an index. The Pixeltable will maintain the index structure for you alongside the rest of the table structure. And so here's another example of how you can do orchestration. So in some cases, you might want to do conditional data flows. Such, let's say you have a a table of videos and you create a view of the videos, a frame view of all the videos. So you might have billions of frames, but maybe you want to do some interesting, let's say, object detection or other embeddings on just a subset of these frames. And you can identify the subset via some search predicates. Keep in mind that you can have tables that contain any kind of data type, including you can have metadata alongside your video that identifies maybe when it was recorded. And you now want to create a view of only videos that were recorded between 6 a.m. and noon. And so you can just create a view for that. And then add more computed columns to that view. So you can have more complicated conditional data flows here. And again, the view will be kept in sync with the base table automatically and incrementally, right? So this is sort of the basic principle of Pixeltable is that all processing is always automatic and incremental. You don't have to think about rerunning a pipeline. And what this also gives you is observability, right? You can look at this view and identify what was it created on? What is you don't unfortunately see, again, I think it's cut off. You don't see the view predicate here. You would be able to observe the view predicate and say, oh, this view only contains videos from 6 a.m. to noon. And these are the specific processing steps that are done on these videos, right? So you can examine what your data sets actually contain. And then very important when you're working with video, you often want to look at frames in a video. And in general, let's say you're working with documents, you might often also want to look at text blocks in the document, right? You typically don't want to have an entire PDF embedded all on its own. That doesn't really work. So you often have to break up documents. When you're working with audio, if you have long audio files, you often need to break those into chunks in order to make them workable with models. And so you have iterators. Again, iterators are also can be user extensible. You can create your own iterators. And in this case, in the example, we are breaking up a long text field into pieces, and particularly using sentences here. So we are again creating a view, a derived table that will now contain one row per sentence of the text field, which was the transcript we looked at as an example in the previous slide. So a transcript might be very long. You might want to embed just shorter pieces. You can just create a view that contains the shorter pieces and now search the view like any other table. And again, like any other table, also create an embedding index on the resulting text field of the view, right? So something that is very common when you're working with embeddings. Here you can do this data processing through the table structure without having to rerun basically pipelines and figure out where to put the output, etc. Again, this is also maintained incrementally and automatically. So every time now you add a new video, it would run through the transcription, and it will then also populate the sentence view and break out the sentences. And if you then have an embedding index on it, it will update the embedding index as well. So a fairly complicated pipeline that is maintained for you automatically and incrementally. And here's just an example of doing exactly that by having a lateral view for video frames, right? So here we have the frame view using the frame iterator, and this uses some now obsolete syntax. And if you look at the examples on the Pixeltable website, you'll see there are a whole bunch of tutorials and examples, cookbooks that walk through this in detail. And we mentioned before, you can augment the built-in Pixeltable functionality with your own user-defined logic. And so you can define user-defined functions that can be synchronous or asynchronous. Basically, it takes a bunch of inputs and gives you an output. Those functions can now be used in any computed column in any of the tables. You can also have user-defined aggregates. So one built-in aggregate is make video. something that allows you to aggregate frames into a new video. So you're basically able to run a query to put frames back into a video. If you broke them up before and did some processing to them, you can now reassemble them. And you can also write your own user-defined aggregates. And there's also iterators. We talked about iterators in the context of audio and video chunking or splitting into frames. You can also create your own user-defined iterators. And again, there are examples on in our documentation. One thing you often care about is versioning when you are creating data sets for model training. You often need reproducibility, and you need to understand how your data set evolved over time. So Pixeltable allows you to create named snapshots. So you can just create a snapshot of a table that will freeze the content and the schema of the table, and you can re-reference it later. And you can also look at the version history of a table and understand what operations were executed on it. So, if you ingest 1 million images into a table yesterday and you do it again today, you can look at it and understand what happened over time. If you change the schema, such as adding more computed columns, you can also see what happened to the table over time. And we last year we launched a data sharing service. So if you're doing data set curation, you can now share the tables that you create locally via the data sharing service. You can think of it a little bit like GitHub for Pixeltable tables. So you can basically replicate a local table and give it a cloud URI, and then your coworkers and collaborators can basically get hold of that table and create replicas locally via the data sharing service. And so this works for all the column types in a table. So if your table contains video, audio, images, etc., those will also then replicate faithfully locally. So you don't have to gzip up like a whole bunch of videos and write some, explanatory text file what to do with it. It all basically lays out nicely and is all usable locally as well. So I think this brings us to the end, and this gives us some time for questions.
Awesome.
Is your system of record time series enabled? Suvasis, could you explain maybe in more detail what you mean? We timestamp all changes. So if you look at the version history of a table, you will be able to see when something happened.
Yeah, I guess that's probably the answer for this question.
Okay.
Awesome. Yeah, so we still got there's another question from Wahid. We still got like 5 minutes left, so yeah, feel free to ask question in the chat, or you can ask live as well, for Marcel and Alison.
We're seeing
We
a
have a
question here.
question. Mhm.
Oh yeah, video to see signs of GraphDB. So you're saying graph database. I'm wondering if Pixeltable will have that storage capability. Clean migration path out of Pixeltable. Do you mean migrating exactly what? It would be interesting to hear a little more detail. You can export Pixeltable data as in a number of formats, Parquet being one of them, or you can also materialize the output of a Pixeltable query as a PyTorch data set. Is that what you're looking for? But to kind of close the loop on that, yes, there are many ways of importing data into Pixeltable and exporting data out of Pixeltable again. And actually, also interestingly, when you have computed columns that use generative models, let's say you create images or you create videos and so forth, you can set a destination URI on a computed column. And let's say, it's an S3 bucket or some other object store bucket, it will then do the upload for you as well. So if you're adding more rows, it won't just do the orchestration piece, it will then also do the data movement into the your desired destination for you afterwards. So, another way to make the data in Pixeltable accessible externally.
Maybe
Okay.
one question from my end is what are some of the new features capabilities that the Pixeltable team were working on for the platform and the open source project in the next couple quarters? Like what are new capabilities that you're like super excited about? Even momentum in the ecosystem.
Yeah. Uh, One thing we're working on actively is extending the Pixeltable API to support serving and REST endpoints. So Pixeltable basically allows you, a table structure expresses a workflow. And
Mhm.
for operational purposes, you will want to be able to use that workflow to serve requests. And so we're working on, right now, you kind of have to wire that up manually. And we're working on extending the API to make that basically, pushing a single button and making that very easy to do.
For sure. Um,
So here's a question about content, crypto content, verify what is said, news related time of the recording. Well, timestamping the video. So this basically illustrates an important point about Pixeltable. Pixeltable is not a sandbox for, let's say, just videos. So if you have a timestamp for every video, you should just add a timestamp column. And when you're inserting the video, insert it with the timestamp. You can add any, you can add a JSON column with far more detailed metadata about any video. Videos themselves have metadata embedded in them, which is part of the whatever encoding standard. And there is a get metadata UDF that comes prepackaged with Pixeltable, which you can simply call and examine the actual metadata of the video. So, there are many ways of adding metadata. And of course, those are all application specific, and Pixeltable does not limit what you can do in your application, right? This is sort of the important thing to recognize. Any kind of custom logic you want, you can put in there.
for sure. Um, yeah, I really like sort of the flexibility of like in Alison's demo, where and you can see the segment on the on the data frames, and you can even play back the clip directly in one of those columns, which is super nice, right? Because it truly like combining multimodal interaction with the traditional like sort of pandas data frame data science data engineering approach.
Exactly. Yeah. And I think that's kind of
Yeah.
the important thing to recognize, that in the end, this is all data. And what Pixeltable is doing is giving it the data a tabular interface that you can interact with, right? So you don't
Mhm.
have, uh, if you use open source packages for all of these, every single piece of data, every data modality will have a different API, and you have to string them all together. Here you have a unified API. And that also means that you can now use, you know, capable multimodal embedding models like those of TwelveLabs much more freely. It's much easier now to say, okay, I'm just going to chunk my audio and then I'm going to throw an embedding index on it, instead of you having to handcraft a pipeline every time you have some new data. It is open source. This was a question. What is our revenue model? We will, in the not too distant future, have a cloud service that allows you to deploy locally developed Pixeltable pipelines, basically serving logic in the cloud with the Pixeltable cloud service, and that will be our revenue model.
Yeah, for sure. Um, I um yeah, I do think like from the use case point of view, combining TwelveLabs embedding model with other, sort of embedding services is going to be very powerful for a lot of our customer workflow. I think in Alison's first half of the presentation, you mentioned a bit of like scene detection, right? And obviously the PDF processing capabilities. These are actually very relevant other workflow that can enhance, 12 apps when we try to like bring it into like, customer use cases, right? So for example, in manufacturing, having the ability to detect scene um, and then use that as like output to fit into our VLM, actually like return better results, right? Rather than just using our own VLM. The other one is that PDF processing one, right? I think like multimodal workloads combining, like let's say security is on one use cases. Now you can get information from a person of interest in like a PDF file, and now you combine that with entity search via Marengo. That will create this sort of holistic hybrid information from that person, and therefore like return like uh, more high query results, right? So personally for me, I'm excited to build application that like can combine not just the multimodal embeddings component from our own model, but also like got the other function within Pixeltable for like other like workflows and modalities as well, just to unlock like new use cases and new value for our end users, developers.
Yeah, yeah, for sure. And that's really the goal, to free the end users from having to do this kind of data processing on their own. So it's easier for them to use these capable models, right? If you have to string everything up yourself, it just makes it harder, and it kind of creates a barrier for you to get the most out of your data.
Awesome. I know we out of time now, so I
Yeah.
guess we can just conclude our webinar session today. I think, yeah, thanks again, Alison and Marcel, for walking us through the slide as well as the live demo. This is definitely one of the like most like technically intense presentation that we are in our webinar series so far. So I really appreciate your thoughtfulness and preparation that you put into it to make the content high quality and educate our participants, right, with the powerful integration and partnership between our two companies. Recording of this session should be available for everyone on YouTube probably like by early next week. So and I'll be sure that to like share with the Pixel team as well, so that you can distribute that in your channels. And yeah, we will run this webinar series on a weekly basis. So for participants, if you found this content insightful and informative, yeah, we'd love to have you join us again next week for more future sessions. All right. Thanks,
Thank you.
everyone.
James, thanks for having us.
Absolutely. And I'll stop recording and enjoy the rest of your Thursday, everyone.